Hello and welcome to kubectl Explain. My name is Paul Tchaikovsky. In this series, I'm going to attempt to demystify some of the resources and concepts around Kubernetes. I figured I should start with something really simple, so here it is. Kubectl Explain Pod. A pod is the base level of compute provided by Kubernetes. Think of it as the smallest deployable unit of computing. A pod is not an application. It's not a container. It's actually a collection of compute resources that are assigned to be used by one or more containers in which your application runs. The contents of a pod are always co-located on the same host and are scheduled and run in a shared context. Effectively, a pod is a logical host that contains one or more tightly coupled containers that make up your application. So what exactly then is a pod? It's a set of Linux namespaces, C groups, and potentially other facets of isolation that are used to isolate Docker containers. Now, in modern clusters, it may not be specifically a Docker container. It might be containerd or even some form of micro VM, but the concept of a pod remains the same. If you're familiar with Docker, think of a pod as a collection of containers with shared namespaces and file system volumes. If you're familiar with VMs, think of a pod as a lightweight VM with just enough of an operating system to run one or more applications. Although the analogy with a VM falls apart fairly quickly. While it is common for a pod to contain just a single container, it's just as common for a pod to contain multiple containers that compose together to create your application. This behavior helps run applications that are made up of multiple processes without having to resort to that generally considered to be a bad practice of running multiple processes inside of one container. The containers that share the pod, they also share resources and dependencies. They share a single network interface, usually an IP address on the pod network and localhost, and they can share file systems. The application running in your containers can thus communicate via networking, localhost, or via the file system, files, or Unix sockets. Like with processes on a VM, care must be taken to avoid network port collisions and similar things inside of that pod. Now, you can ensure that your pod receives enough compute resources by setting resource requests. And these let the Kubernetes scheduler know that our pod needs to be scheduled to a node with a minimum free amount of CPU and memory. You can also set resource limits that will set a maximum amount of CPU or memory that a container in your pod may use. As well as your application containers, a pod may contain one or more init containers. These init containers are fully executed before your application containers start. This allows you to perform actions such as transform a configuration file or collect a file from an object store to be consumed by your application. Pods are designed to be ephemeral or disposable entities. When a pod is created, it is scheduled to a node in your cluster. The pod remains on that node until you ask for it to be removed, or it finishes execution, or if the pod is evicted due to lack of resources or the node it's running on fails. It's rare you will actually request a pod directly in Kubernetes. You will almost always reach for resources that manage pods, such as deployments or jobs. These resources are managed by controllers that wrap the fragility of a pod with resilience. For instance, a deployment, the controller manages one or more copies of a pod and will replace failed pods. And we'll talk about deployments in a future episode. So let's actually go ahead and put this into practice. Here we have a very simple Kubernetes manifest. All Kubernetes manifests share the same structure, and that is they have an API version, they have a kind, they have metadata, and then they have some sort of spec or data. This is a pod manifest, and it is requesting a very simple pod, one that contains a single application which consists of an Nginx image. I'm also setting some resource requests and limits. When I run kubectl apply against this manifest, I will get a pod. And that pod will run my Nginx container, and it will be assigned an IP address. If I was to access this pod on the Nginx port, I would get the default Nginx welcome page. Not very exciting. So what would it look like to get an interesting website into my Nginx container? So here's a slightly more complex example. Here I'm still using Nginx, but I'm using an init container to git clone a website into a shared volume which both containers can access. So when I pass this manifest to Kubernetes, I'll first of all get a pod with my init container running. And that init container will run the git clone command, and it will clone that website down to our shared volume. When it finishes executing, my Nginx container will start, and it's mounting that same shared volume into user share Nginx HTML. And that is where Nginx expects to see HTML files. Now, if I was to access my pod, I wouldn't get the default Nginx welcome page. I would get whatever website is hosted up in my Git repository. So that's it. That is kubectl explain pod.